The world of plastics is changing. Digital technologies and AI are driving this transformation, making the industry more sustainable, less waste, healthier planet, embracing digital tools and AI, enhancing efficiency and innovation, a digital future full of opportunities.
Digital tools are transforming traditional polymer factories into smart factories. These factories are more efficient and produce higher quality products. Automation is a significant change. Robots take over repetitive tasks. This frees up human workers for complex tasks. Robots handle precise chemical mixing, ensuring consistency and reducing errors. Digital twins play a crucial role. They optimize processes before real-world implementation. This minimizes waste and downtime.
Data analytics is critical in the polymer industry. By analyzing data, manufacturers gain valuable insights. These insights improve efficiency, reduce waste, and enhance quality. Sensors collect real-time data on various parameters. This data reveals patterns and trends. Manufacturers make informed decisions, optimizing processes and ensuring quality.
Leading chemical companies like BASF and Dow Chemical are at the forefront of this digital transformation. They are investing heavily in digital technologies and AI to optimize their operations and develop innovative materials. BASF, for instance, utilizes digital platforms to connect its global operations. This allows for seamless data exchange and collaboration among its different divisions. This integrated approach enables BASF to respond quickly to market changes and customer needs. Similarly, Dow Chemical has implemented AI-powered systems to optimize its production processes. These systems analyze data from sensors and other sources to identify areas for improvement in energy efficiency and waste reduction.
Industry 4.0, the next generation of manufacturing. The digital transformation in the polymer industry aligns with Industry 4.0. Industry 4.0 integrates digital technologies into manufacturing. This includes IoT, cloud computing, and AI. In polymer manufacturing, it creates smart factories. These factories are automated, data-driven, and interconnected. Machines communicate and share data seamlessly. This allows real-time monitoring, control, and optimization, improving efficiency and quality.
Artificial intelligence is revolutionizing polymer material design. Traditionally, developing new polymers was a time-consuming and labor-intensive process. Researchers had to rely on trial and error, experimenting with different chemical compositions and processing conditions. Now, AI is accelerating this process significantly. AI algorithms can analyze vast databases of chemical structures and properties. This helps to identify promising candidates for new materials with specific characteristics. For example, AI can be used to design polymers with improved strength, flexibility, or heat resistance. This opens up new possibilities for creating innovative products and applications.
AI is also playing a crucial role in predictive analytics for polymer formulation. This involves using AI algorithms to predict the properties and performance of a polymer based on its chemical composition and processing parameters. By accurately predicting how a polymer will behave under different conditions, manufacturers can optimize their formulations. They can ensure that the final product meets the required specifications. This reduces the need for costly and time-consuming physical testing. Predictive analytics enables manufacturers to fine-tune their processes. This ensures that they are using the right materials and processing conditions to create high-quality products.
AI-powered tools are invaluable for optimizing production processes. AI optimizes resource consumption. They analyze data from various sources. This helps identify resource waste. AI suggests adjustments to reduce waste and improve efficiency.
Sustainability is no longer just a buzzword in the polymer industry. It's a necessity. The industry is increasingly aware of its environmental impact. It is actively seeking ways to reduce its footprint. One of the key challenges is reducing plastic waste. Plastics are durable and long-lasting, but this also means they take hundreds of years to decompose in landfills. This contributes to pollution and harms ecosystems. The industry is exploring various solutions to address this issue. These solutions include developing biodegradable and compostable polymers, as well as improving recycling rates.
While the digital revolution and AI offer tremendous potential for the polymer industry, some challenges come with integrating these technologies. One of the main challenges is the lack of skilled labor. Implementing and managing these advanced technologies requires a workforce with expertise in areas like data analytics, AI, and automation. However, there is a shortage of skilled professionals in these fields. Another challenge is the resistance to change. The polymer industry has been operating in a certain way for decades. Shifting to a more digital and automated approach requires a cultural shift and a willingness to embrace new technologies.
A look into the future of polymers. The future of polymers is intertwined with digital innovation, AI, and sustainability. Expect more innovative and sustainable solutions to emerge. Bio-based polymers are made from renewable resources. This reduces reliance on finite resources and supports a circular economy. Self-healing polymers can repair themselves, extending lifespan and reducing waste. Thanks for watching. Don't forget to like, comment, and subscribe for more insights into the world of polymers.